I wouldn't trust me with it.
All right, ladies and gentlemen, so hopefully you had a great, wonderful, fantastic weekend. Hopefully the fast forward an hour is not killing you too bad. So we're going to start off with something different. Let me put this up so that it don't go back.
Hurry, someone close the door.
I have the key.
Shoot.
Stand in front of it.
Somebody that's really strong to hold the door.
All right, so Mr. Hall wants to formally apologize to all of you for the way that Mr. Hall spoke last week. Mr. Hall said a word that he thought meant something that it did not mean. And Mr. Hall put his foot in his mouth. And you all, if you think back to it, should know the word I'm talking about. Because whenever I wrote the word and I said the word, and I heard, I was like, that word don't mean what I think it means. So stand. So then afterwards, I looked up what the word meant, and I went, oh my God, Lord Jesus, forgive me, I said that. I thought the word meant like simple. Does not mean simple. I felt awful. I apologize. Think of a way that you could abbreviate simple that would not mean simple, and Mr. Hall would be apologizing to you right now. So I apologize. Mr. Hall does not speak that way. I am so sorry.
I really didn't think it meant anything bad.
Oh, I looked it up. It means something bad.
It's not that bad, Mr. Hall. It's not that bad.
You didn't read the definition I read.
I'm not joking.
There was 2 definitions. And the first one I was like,
Let's just go with the second one.
second one's still bad. Not as bad, but it's still bad. Okay. Let's say it that way. But, whew, it's been a week. This is an exciting week for us, remember?
It is.
Yes, we have special guests coming in. We do. They will not see you in this room because they're supposed to be here at 8. And at 8, you leave, so.
Don't we have a test?
You do?
When is that?
And it's Thursday.
I thought I'd be here Thursday.
Why don't you do the physics quiz on Thursday?
Everything.
And then the chemistry quiz to
I actually do need to talk to you. Y'all are going to go nuts, and I know y'all are going to
Will that go on?
spread the word. So by, no, it would start 49 weeks.
That's a good way to start.
So I know like everyone else in the class will figure out before the 3rd period is even started. But I am going to talk to y'all about possibly moving our study session and quiz because first off, I got to go, my plans got changed. I'm helping install some lights today
That's not fair.
for a friend. And then you looking at me and telling me it took you 45 minutes to solve one of those problems has me kind of concerned.
We could have been done in 3 minutes if we would have had someone to tell us if it was right or not.
I mean, we did pretty good finding the name and stuff. That's about all I know.
See, the problem was is 3 people got 3 different answers, and we were all convinced that our answer was right.
Very nice.
Oh, chemistry or physics?
Physics.
Oh, I'm talking chemistry.
Oh, we didn't
You're
know how
okay.
to do the chemistry.
No.
So, on this, you guys, we will, we'll look at that. So I'm taking it as your all's excitement that you're cool with moving it.
Oh, yeah.
Yeah.
Can you move ours? What? So ours ain't moved? Oh, my God.
I
I
already
was
moved y'all.
thinking he's moving ours.
I already
And we're talking
moved
about
y'all.
physics. We'll move it again.
We didn't get the members last week. But we're gonna fix it.
Yeah, you did.
Well, let's move it again.
It was supposed to be Friday.
Well, let's move it again. Can it be Monday?
It's the hard one. It's the
You consider the polyatomics the hard one?
Yeah.
Oh,
It's
excuse
the
me.
hard one.
When you make a 10 out of 30, yeah.
I will say this, y'all did not do too hot. Alright, so we started out with nomenclature. And I want to keep up with it today. I want to keep moving. In this, we're going to keep going on, keep practicing these, keep working with these. I don't expect you to have a really strong comprehension and understanding of it at this point. because I kind of just unloaded and throwed everything at you. But we're trying it kind of in a different way. We're trying to mix everything together. And yet again, from the bottom of my heart, I deeply do apologize for saying that word. I'm so sorry.
What definition did you find that was so bad as that word?
Don't look it up. I would feel awful if you went and looked it
Well,
up.
now I kind of got to,
Yeah.
but I'll do that later.
Let's just, whenever you read it, if you know me, you know my character and how I live my life. As soon as you read it, you're going to go, oh, this is the one he read. So in this, nomenclature-wise, so just starting off. So if we were naming some things. So what you'll see is you guys will start coming in here. And I'll probably have this pulled down. And I'll have some practice problems for you guys behind this. Okay? So that you guys can't see them. We'll pull them up. And we're just going to repetition. We're going to keep crunching these. And you just got to keep naming. Time and time and time again. I'll throw the tricks in there. Your first nomenclature quiz is not as bad. The second one kind of is like no holding back. It's full force, run you over, like
I think
smashing you in the face.
Yeah, that's probably the first one.
Yeah, okay. Anyway, so if we had this, what is this? Sodium. What is this?
Sodium.
Sodium. Very nice. What's the difference between the two?
One has a positive charge.
Let's go more scientific, not as simplistic. You are 100% correct. But what would we call this?
Cation.
Cation, what we would call this, starts with an E.
Element.
Element. So this is an element, this is a cation. They're both named the same because they are, that's how we name cation. In this though, let's say we added something to this. So we have sodium and chlorine bonded together. So here's the key, and this is how you have to start thinking whenever you look at this. Sodium and chlorine's together. First thing, two things bonded together. Sodium comes from the left side of the staircase, so it's a metal bonded to chlorine, which comes from the right side of the staircase, which means it's a non-metal. So I have a metal and a non-metal. What type of bond is it?
Covalent.
Nope.
Ionic.
Ionic. So, we're looking at ionic. So we name this based off of the ionic naming rules. So in that, we are literally going to name the ions in it. So whenever you look at this, this is the key. Look at sodium. Sodium has a positive charge. Why do we not see the positive charge? Because the chlorine has a negative charge. So guess what happens? The positive and negatives balance out, and there's no overall charge. They're hidden. You have got to be able to notice hidden charges. I am going to hide charges like nobody's business. It is the simplest way for me to make the problems tricky and to prepare you for whatever college has to throw at you in chemistry. So I absolutely, positively, will hide the charges. So you don't see the charge here, but what's this one named?
Sodium.
Sodium. Then when we get to this one, this is where I don't expect you to have the background yet. This is an anion. Bingo. This is an anion. So we keep the root, chlor, Remove the ending. The ending on this would have been INE. Remove the ending, add IDE. So this is sodium chloride.
So how do you tell if it's an anion again?
Whenever you look at it, you're looking at where it comes on the periodic table. So if it comes from columns 15, 16, and 17, they will form anions. Because column 15 have 5 valence electrons, so they'll pick up 3. So they'll have a 3 negative. 16th column will pick up 2 electrons. 17th column will pick up 1. The first thing you're going to look at, Sonny, what type of bond? If it's an ionic bond, then you automatically know you're going to name based off ions. Does that help? So it's like the dead giveaway. What I like to do is at the very end, and the video is probably still out there on YouTube. If you want to go look at it, you can. I wouldn't recommend it yet. What happens is I go through all the nomenclature rules. After I hit all the nomenclature rules, then I draw out a map that is the thought process of how to name things. And it's pretty big, but it's literally how I progress through my mind mentally when I'm naming these things. And it helps some kids that don't, but I like to do it because it gives you kind of like a roadmap to see what I'm thinking mentally when I do it. So let's say I did the flip of this. So this is where things can get tricky. If I gave you the name and I wanted the formula, so let's say I gave you calcium fluoride. You haven't seen one of these yet. In this, it's calcium fluoride. When you look at the name, are there prefixes with it? When I'm saying prefixes, I'm talking that stuff I gave you to for the covalent bonds. No. Come get it. If you were not here Thursday, you did not get it. In this, welcome. There's no prefixes. Look at the first one. It's just an element name. Look at the second one. It ends in IDE. So we can tell this is coming from calcium. This is coming from fluorine. Calcium's on the left side of the staircase. Fluorine's on the right side of the staircase. We have an ionic bond. So now we can pull the information apart from this. This is the key. First, keep the ions separate. So what I mean by that, write them out with their charges separate first. So calcium, for example. What charge will the calcium form?
+2.
+2. Nice job. Remember, sign comes second. Yet again, some of y'all put the sign before the number on your polyatomic ion quiz. I didn't take off of for it. It's a good thing I didn't, because it would have been really, really bad. Fluorine or fluoride. F. Fluoride. What charge?
Negative.
There we go. So F negative. So in this is why I say keep the charges separate. There's a method that we call the cross method. And this is what we typically do to make this as simple as possible. You take the charges and you cross them over. But when you do that, you just take the number with it. So this 1 comes down for the calcium and the 2 comes down for the fluoride. So we have Ca, and right here we put the number that is the charge up here. So there's just a 1, so I don't put 1. So then I have fluoride, so F But there's a 2 over here, so I have to put a 2. Now the reason we're doing that is because when you look at it, what's the charge on the calcium? Plus 2. There's only one of them, so the overall positive charge is plus 2. That means the overall negative charge also has to be this, but opposite in sign. It has to be negative 2. So if you've done this right, this will balance out. So what's the charge on the fluoride? It's negative 1 times 2 equals negative 2. And that's just a nice way to kind of check yourself a little bit and help yourself out. This is calcium fluoride. Now in this, there are some times that you're going to see, you're going to do the cross method, but it's kind of like whenever you deal with fractions in algebra. If you had a number that was 2 over 4, what would we do?
Make it 1 over 2.
We would simplify it and make it 1 over 2. It's kind of the same thing here. So if I gave you something like calcium oxide, do the same process. Stay with the same word. Write your elements down. So we got calcium. We have oxygen. When you look here at calcium, what's the charge on the calcium?
Plus 2.
2 plus? Positive 2. What about the charge on the oxygen? 2 negative.
How do you find the 2 positive and 2 negative?
It's all coming off the periodic table. Whenever you look at it, it's all based off what column they're coming from. So when you look at it, remember the D block don't matter. Neither does the F block. We just care about S and P. So in this, the first column will form a plus 1. Second column will form a plus 2. The 13th column, because we jump all the way to 13, just remove the number. So plus 3. And then the 14th column is kind of the same. That they like covalent bonds. I'll just tell you straight up. They don't like ionic bonds. So we don't worry about the 14th column. But then at the 15th column, it'll switch. So I kind of keep it in my mind, the 14th column is the switch point. Then now I start working backwards and I change my sign. The 15th column will form a negative 3, 16th, negative 2, 17th, negative 1. The reason behind that is all on how many valence electrons they got. I'm looking at the whole room because I know, thank you for asking that, because I know many of you in this room are probably asking that question to yourself. How am I getting this? Where's this coming from? In all of this, it's based off of the number of valence electrons they have. What's the number of valence electrons in the first column? 1. So is it easier to lose 1 or gain 7? Lose 1. That'll give the full octet that it's trying to achieve. Second column has 2 valence electrons. It's easier to lose 2 than it is to gain 6 to get the full octet. Oxygen, for example, is in the 16th column. Is it easier to lose 6 electrons or gain 2 electrons? Gain the 2. So that's why it forms at negative 2. Does that help? Good question. Alright, so in this, follow the same method you looked at. We're just going to cross them. 2 goes there. 2 goes there. So calcium, 2 from the oxygen. And we have oxygen, 2 from the calcium. This is where I'm talking. We're going to simplify this out. If you gave me this for calcium oxide, you are wrong. Because this can simplify out. This applies only for the ionics. This does not apply for the covalents. Covalents are different. The covalents use the prefixes, and you best know your prefixes. Those go by a different set of rules. When you deal with covalents, we will not simplify. You deal with ionics, you will. So what can I take out?
2.
I can take out 2, leave me with 1, right? So there is calcium oxide. And if you check it, you'll find out. Positive charge coming from the calcium is a +2. The negative charge coming from the oxygen is a -2. They balanced out. You cannot give me this. Do not give me that.
Are all ionic bonds going to balance out?
Yes. They will always balance. Where's my eraser? Tack right on the board.
Not for this place.
We did for physics.
What did you rascals do with my eraser? Christy still it?
Yeah, I'm like Christy.
She probably did. Why you always keep a spare.
Mr. Hall, she's home with a eraser.
Good. I done moved on. I blame Christy. Christy's fault. Y'all tell Christy I said that. She'll come crying later. Okay. Still staying in with the ionic bond idea. Say I gave you, let's keep it simple. All right. So what's the 2 elements I gave you here?
That would be
Iron and oxygen. Good job. In this case, whenever you're looking at this, there should be an alarm that you should build within yourself. That as soon as you look at it, you go, well, I got iron. Iron's from the left side of the staircase. Oxygen's from the right side of the staircase. It's ionic. There should be an alarm that goes off when you look and go, okay, iron's from the D block. You should go beep, 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 beep. You should panic. Because in that, you don't know the charge. So you have to work to find the charge. See?
sounds hard.
No. It was so simplistic that on Thursday, when my freshmen came into this room and they seen the math in this board, they went, that's all y'all do, chemistry? I can do it. Oh, you ask them. They all going on. It's like, I can do that, man. And I was like, yeah, you should sign up for it.
Is that not considered like playing devil's advocate?
No.
No, you're going to show them the easy stuff. Have them sign up and be like, this was what you showed us last year.
I'll be like, it ain't my fault you didn't pay attention to the whole, like, whenever you walked in, it looked like we were solving a rocket science problem on the board. So, in this, we have to find the charge on the iron. The easiest way to do this, look what it's bonded to. It's bonded with oxygen. Do we know the charge on the oxygen?
Yes.
Yes. So let's work from there and work towards the iron. So in this, what is the charge on the oxygen? -2. How many oxygens we got? 3. -2 times 3? -6. I should write more of this, like make this bigger on the board so when the freshmen and sophomores like walk in, they're like, there's no way chemistry is that hard. They're just doing multiplication of single digits. I can do that. kind of like my recruitment method's not working, so maybe I can like trap them in.
Make it look super easy, that way they're like, yeah, I can do chemistry.
That's what we're gonna start doing.
I'm gonna start forwarding your videos to everybody.
This is what chemistry really is, don't stop.
Maybe if
You're
you gave us all bonus
horrible.
points and brought all of our
Shut up! No bonus! No!
to an
We will
A.
tell every kid in this building.
Yeah, if we get bonus, we'll go brag about how nice chemistry is.
I'll
Have
go over
everybody
the
sign.
intercom. Be like,
We'll make announcements.
He'll just turn it down.
Well, it's just one room. Okay, that has the overall charge for the negative. The overall positive charge, since there is no overall charge, has to be equal to that but opposite in sign.
6.
Equal in magnitude, opposite in direction.
I
Yeah.
don't know what that is still.
Oh, God. Oh, help me, Jesus.
Help us too.
Okay, that's just saying it's the same number, but with an opposite sign. So there's a plus sign. See? Now divide that,
And why are we dividing?
because we're trying to find the charge of a single iron.
So you divide? Oh, okay.
See? By the number of irons you got. So I have 2. Gives me a plus 3. Now I can name this. Because I now know the charge on the iron. Because remember, when you deal with transition metals, you absolutely will, shall positively, use Roman numerals. This is not AP chemistry, so I will not have you memorize the 2 that only have a fixed charge.
There's an AP chemistry?
No, but I'm hoping there will be here in next year.
Nobody will take it.
You have one chemistry class right now.
Nobody's taking your original chemistry. We'll learn your version.
I give it out there, and I tell the kids, I'm saying, you take chemistry. You would be valedictorian, I got this AP class.
You will not forget something.
You get an A. Yeah.
No, they won't.
Increase your GPA.
Don't lie.
They gotta get that A first.
They'll have hope.
Yeah, I had hope too.
Will they have bonus points?
If you have it, they will sign up for it. That's what I keep telling myself.
Bonus points for every kid I can convince.
Yes.
Yeah. Let's do that.
I don't know if I want that deal. That may be a bad deal for me.
No. We need a canned food drive.
Okay, so in this, name it, first element, iron.
If I bring you some like Lysol and hand sanitizers, can I get some bonus points?
You need it in my spoon.
Yeah.
Do you need your lawn mowed?
Don't do that. What about laundry wash?
I'll watch
My wife handles my laundry. My wife also cleans our house, keeps it very nice and clean.
Although she
We'll
didn't
give her a
have to.
break.
I mow and take care of my lawn.
Get for a massage and let her go, and I'll clean up.
At this time, any senior who would like to sign up for tomorrow night's game, versus these, please secretary, please.
Tom! Yo, sign up later, man. We're doing chemistry. Tom! That's the fastest I've ever seen it. All right, what's the charge on the iron?
3.
So what Roman numeral we put in this parenthesis?
3.
Very nice. You guys are catching on. Now we deal with the oxygen. Remember, you're dealing with an ionic bond. So we name the monatomic anion. Big fancy way of saying we're going to name oxygen. So in this, write the word down. Remove the ending. YGEN.
Fed outside.
Add IDE to the end. I know what you're thinking right now. Mr. Hall, you make this so complicated. I'm trying to give you a pattern to follow. See? So in this is the one where it gets really tricky, where you have to be able to go both ways. And here's where it doesn't get tricky if I give you the name. If I give you the name and the charge, I make your life simple. So, let's say I give you copper 1. Ooh, that was awful. Copper 1, that's the number 1 for a Roman numeral, not I. Oh, by the way, that reminds me. Some of y'all wanted to put CiO negative for hypochlorite. That's an L, not an I. Throw that out there. So copper 1 sulfide. This is where life gets simple for you. I gave you the charge. So write down copper with the charge. Remember, we're keeping them separate right now. Then we got sulfide. So we're going to write down sulfur. What's the charge of the sulfur? Or the sulfide, sorry.
-2.
Why is it -2?
Because it's in the 16th column.
Because it's in the 16th column. So put negative. Now what you going to do about it?
Do the cross.
Do the cross, yeah. Like a rap song for that, man. Boom. Boom. So let's write it down. So I got copper. I got a 2 coming from the sulfur. I'll put a 2 down here. Then I write down the sulfur. I got a 1 coming from the copper. I write any number next to the sulfur. No. By the way, I want to stress this out to you. You see how these things are subscripts next to them? That's important. Make sure they're
Those
subscripts.
students are on their way back. Any junior that needs to sign up, come to the cafeteria.
Where are you going?
I'm gonna make Thomas.
We're doing chemistry! Yo! Hey! What you doing?
I'm going to go sign up for there.
I bet see you at the game!
I'll be there with bells on. If I give a tree on here, come on, point.
If I had $1 for every time I heard bonus points in this class. Okay. Can this simplify anymore?
What is that, Bill?
I have no idea. It was weird. No, I think that's where they need a janitor.
You could possibly.
I'm back.
What is their
No, it's
time
one. It'd be
change?
1.
Exactly. I can't simplify it anymore. There's not a 2 here, so I can't simplify it out. Right there is copper 1 sulfide. That is what we are talking about whenever I'm saying that I'm making it more simple on you. Okay? Going from this to this is where it gets hard. And you have to catch D block element. Set an alarm in your head. Capiche? Capiche. Now, that was a very weird bell, but I'm pretty sure that was the bell. But let me talk with your wife. Right. We'll see what you got. Here we go. So, on the first one, strontium bromide. You can tell by how it's named. We're dealing with an ionic bond. So in this case, we're going to write down what we got, and we're going to put the charges with it. So first one, strontium. Good job. Get ready to ask that. What's the charge? So 2 plus. Bromide? Br. Charge? Negative. So then, we're going to combine them together. But when we do this, we do the cross method. So the 1 comes down for the strontium. Do I put a number there? No. No. So now let's look at Br. What about Br? I put a 2 from there. Can this simplify out anymore? No. Boom. Done.
Let's have a quiz on that right now. Just like problems like that though.
I wouldn't.
You want to quiz on nomenclature right now? Oh, God.
Just on that.
I'm ready to go. Let's put the print, baby. Let's do this stuff.
All right, let's do it.
On
Just
problems
slow
like that. The easy
Bonus
one.
points if we do it now?
Anything exactly like that first one.
Just that, and then the second one can be garnished.
Yeah.
Taking both
Yeah.
of them.
And like
We
double
put
garnish.
it to 100 points.
Yeah.
All right.
Can you imagine failing?
Second one here. Whenever we're looking at it, we're trying to find this. This is the key. Like I said, whenever you look here, I got Fe, which is iron. Iron is a D block element. So that right there, red flag. Alarms are going nuts. They're like, whoa, 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 whoa. Or however your alarm sounds. I don't care. Then you got sulfur. So in this, we know that we're going to be looking, since it is a D block element, a transition metal, what we're going to be doing is naming it with a charge. So iron, and then we're going to put parentheses, and there's got to be a charge in here. Sulfur, we just name it as the monatomic anion. So sulfur, remove the ending, add IDE, so sulfide. Now in this, we got to figure out what the charge is. To figure out that charge, we work backwards from the sulfur. So what's the charge on the sulfur?
2.
So -2, how many sulfurs we got? So I multiply those together, it gives me -2. The overall charge, positive charge, also has to be equal to that, but opposite sign, so +2, divide it by the number of irons I got. How many irons?
1.
So +2 divided by 1 equals +2. So this is iron 2 sulfide. Not just iron sulfide, iron 2 sulfide.
So we did. So far, so good.
Nice.
All right. Lead 4 phosphide. I gave you this one like this for a reason, because whenever you get down there, look where lead's at. Technically, lead is sitting in the P block, but it's so far off, lead actually acts as a D block element. So you will see a charge with it. You have to name it with a charge. So in this, I have lead 4, so I write it down. And phosphide. What's phosphide come from?
Phosphorus.
And what's the charge on phosphorus?
3.
So now, do like what we did before, cross method. Can that simplify anymore?
Isn't that what we just had though? Wouldn't that change? There we go.
Yes. There's too many P's.
Yeah. I just got so confused.
Good catch.
Wait a minute.
So PB3, P4. Questions?
Nope.
Then my personal favorite. What you get over here?
I don't know because is it an ionic bond?
I'm so proud! Yes!
Should I leave?
Woo! O2. Why O2?
The diatomic.
It's a diatomic. Your 7 diatomics have not left you. Your 7 diatomics are still involved in this class. Don't you dare think your diatomics have left you and they are gone. Ladies and gentlemen, they are still involved in this class. They are still here. They are still happening. And that right there is a beautiful little trick that I can throw at you.
Let's quiz.
Right now.
All right, nomenclature.
No.
You know, on second thought, I'm illiterate, can't read.
Man, you made it really far.
Can we take a field trip?
And our favorite rocket ship.
Magic school bus.
Get ready for this board.
All right, we're going to keep doing these, okay? We'll keep doing repetition like this for every class. Why are you putting your stuff away?
Oh, are we not done?
What time is it?
We have like 5 minutes in here.
That's 5 minutes of chemistry. Get that notebook
You
out.
sound like she drinks mother.
Miss Cole. That's who you sound like, Miss Cole.
That's where I think they're all related.
We got
So,
That's 5. That's probably
in this, we went back through with ionic bonds. Now, I want to go back to these covalent bonds.
This is where I go downhill.
The important thing to remember with covalent bonds, you use prefixes.
Oh, does that apply to like madam, sir, Mr.?
Yes, show respect to every one of them. In this, we're going to use the prefixes that I gave you. I don't know where mine are sitting, but I had some left over. Aha! These are the prefixes I speak of. If you do not have this, come get this. All right, so in this, you're going to use these prefixes. This is the thing. Charge, no matter. It's quite interesting. Normally I would have done S2O, but I guess you wouldn't have done it that way.
I hold this up in physics all the time.
They show the camera.
Can you keep that?
All right, look. Here's the key, and here's the thing. In this, and this is where I want to stress it, with your prefixes. You will always, put the Y first. Use prefix. Except and only except probably the comma there. If the first element in the molecule
Continue.
is or has, it goes with has. Only one do not use mono with first element. This is the only case. This is like the guarantee. If it is the first element, it cannot get mono. So it can go around kissing whoever it wants.
Are we done?
You put that up and so help me. I'm gonna like flip my desk or something. No.
I will pay to see that.
Here.
This is the key. Do not use mono with that first element. Absolutely, under no circumstances, will you ever use mono with the first element. Do I make myself clear?
Yes, sir.
You will only use the prefixes with covalent bonds. How do we identify covalent bonds?
They're out of sync.
Why do you call it a snake? What kind of snake have you seen that looks like that?
Because
lot,
got some
believe it
issues
or
with
not.
burning out.
You know that?
It's got a lot of right
that one
angles.
game on my pool map where it eats the apple.
I'm not talking up. You identify it by non-metal and non-metal bonded together. It will be to the right of the staircase, not the snake, the staircase.
It can be whatever it wants to be.
No, it cannot. It is a staircase. It's been labeled and named.
Mr. Hall.
It's a snack.